Okay, so good afternoon. Welcome back to our lecture session. Today we will discuss the last part, that is the computer integrated manufacturing. If we go to the our course curriculum or the syllabus content, this computer integrated manufacturing is the title of the particular course, which encompasses all sorts of activities where there is a wide spectrum of application of the computer computer activities like CAD, CAM, CAPP, CAP, everything comes under the broad heading or the broad title of computer integrated manufacturing. Before going to the details of it, let us have to the historical background. The concept of intelligent manufacturing system was formally introduced in 1989 by Japan and subsequently as next generation manufacturing system by US in 1995 to offer flexibility, adaptability and responsiveness in advancing the manufacturing through intelligent decision making. Objective was that when computer system was introduced in the 1970s and proliferated afterwards, then finally the computer aided manufacturing system came into existence, and computer integrated manufacturing is the highest level of the enterprise level of automation under which all sorts of activities come as an island of automation. But the critical or the typical dimension of the characteristics of the computer integrated manufacturing is that different island of automation could be integrated through a common database and the communication systems. So, intelligent manufacturing system was developed in 1989 and subsequently in 1995 by US with a different name. Objective is same, to advance the manufacturing activities to the automation and widespread computerization. CIM is where the most prominent manufacturing system of the paradigm considered under the umbrella of IM during 20th century. So whenever we talk about even the concept of intelligent manufacturing system or NGMS is also equally prevalent in 2025, but now due to introduction of the industry 4.0 and 5.0, where AI/ML, IoT, data science, cloud computing, these are also playing very extremely important role. And now the focus shift from the programmable automation to so what is called data centric or data intensive automation under the broad title of intelligent manufacturing. But this present trend is popularly known as smart manufacturing. So before we go to the details of the computer integrated manufacturing, it is imperative to discuss what are the different activities that broadly comes under the broad title manufacturing. Manufacturing is basically comprised of several interrelated activities starting from the product design and documentation, selection of the materials, that is the inventory control and its management, production of course, quality assurance, warehousing, marketing. That means manufacturing encompasses wide varieties of activities which are essential to convert the raw material from the early stage to the final delivery by different type of activities to be carried out under the umbrella of a central heading, that is the manufacturing, and production is one such activities. Production is the exclusive of the part when the raw material is being converted by undertaking some processing activities to different basics of the resources of the equipment. So we can say that production is basically a subset of manufacturing. Quite often manufacturing and production is used interchangeably, but perspective of the manufacturing is much broader as compared to the production. Now, what is the CIM background? Whenever we talk about any new paradigm or new trend of the system, it is always imperative to have a look what are the different challenges existing over there in the market or in the system itself, and what are the technologies which are coming which can deal or the cope with that particular challenges. Now the challenges prevailing in the market can be categorized under the two broad heading. One is external challenges. What are the major attributes? Shorter product cycles. In contrast to the earlier manufacturing scenario or market of the business, the manufacturing has undergone several changes but the duration of the products is rather limited. People, you cannot expect that people will buy a particular product and it will use for that, say, coming 20-25 years, those days are gone. Now the product having smaller cycle or smaller duration of the lifespan, whenever it is finished or its performance is not that much satisfactory as it was maybe a couple of years back, people or the customers are looking for something new. So the duration of the life of the product is rather low as compared to the earlier one. Greater product diversity. In the current days, number of products which are available in the market in any segment or in any category, those are highly diversified. Diversified in the sense, due to the widespread use or the presence of the competitors, thanks to the globalization, different manufacturer coming up with a new product that makes it possible that in the market wide product diversified products are available. So it is solely the prerogative of the customer to select a particular product from any particular manufacturer. Stringent quality. In the present scenarios, people or the common people or the customer are not willing to compromise in the quality. So performance, and that is the quality, whether it is a functional quality or aesthetic quality, people are very fastidious about the stringent quality requirement of the product which they are willing to purchase. Demanding and sophisticated customers. Now, niche customers will be looking for very sophisticated and the demanding product. Demanding means quite a good number of critical features should be present in that particular product so as to satisfy the typical need of that particular customers. That is why the products have become much more sophisticated. If you think about it, a very good example would be your Android phone as compared to the press button type of old phone. Quite a good number of demanding and sophisticated features are there. Another very common example in our society would be the current days car are having lot of added facilities of the features as compared to the old days car. So that attract the eyes of the customers, which the business house or the manufacturing house obviously supposed to be satisfied. Availability of the diverse alternatives, global competition. See, the current days market is basically globalized market. So unless and until all these requirements of the quality requirements, the performance is satisfied, it is very difficult to sustain and to attract the customer in the global market competition. Fragmented and the niche market. In the current days, once again, thanks to this globalization, the market is global. So any manufacturing company across the globe, they have got the ample liberty to make their business in anywhere in the world. So under that circumstances, wide varieties of facilities and products are available. Now, some products which are extraordinarily costly, they may have some very unique feature, and that creates what exactly is called a niche market. That means only a very small segment of population will be looking for extremely high valued car or a high valued product having a very typical features. So that means all entire 100% population are not willing to buy a particular product. So market is basically fragmented. That is what exactly is called niche market. Increasing labor cost. As the automation increases, the possibility of the labor cost or the quick mobilization or abundant supply of labor is becomes very difficult. That, in other words, enhances the labor cost. Cost of money. The cost of money, that means if we think about our Indian perspective, the value of our rupee is keep on decreasing as compared to the US, what is called US dollar. So that is why the cost of money also need to be considered in while taking up your project for new product development. Internet has got two of the multifaceted contribution. In one hand, it establishes global communications very easily, very efficiently, but at the same time, it creates a provision for stiff competition. So the company which are in business, they can have the information what their competitors are doing, what are the uniqueness of their competitors' product, which they will be able to, or which they will be attempting for duplication or something like that. Partnership and alliance, that is also become extremely popular. See, the competition is very stringent, so it may not be possible for an individual company to run the show as an individual. So under that circumstances, the concept of merger, partnership and alliance also becomes very predominant. And when the two major companies club together or merge together, they become a very potential player in the market. Some good example would be say Maruti Suzuki. So Maruti in one hand, Suzuki Motors in the other hand. So their combination is one sort of merger. Similarly, Nissan, Mitsubishi, Toyota, these are also a merger. In a medical fraternity or the pharmaceutical, this is a very recent couple of years back, Ranbaxy, which was earlier very popular, that was acquired by the Sun Pharmaceutical. So that these are some of the good examples of the partnership and alliance. So all these parameters of the attributes are pose a stupendous threat and considered as external challenges to the manufacturing unit. Coming to the internal means for the organization, internal people, internal departments, those broadly can be having conflict between the marketing and the production. Marketing people will be looking for the high turnover. More the higher the sales, higher will be their prospects for their own growth. But it always may not be in good agreement with the production objectives. Production people will be looking for complex product generation. If they can develop complex product, they can manufacture with their existing facilities, to their knowledge, to their expertise, they will feel proud of that. Sophistication production system. So if the production system comprises very sophisticated equipment like CNC, CMM, robotic system, HEVs, they feel proud that we do have our very sophisticated production systems. Product and volume mix. But quite a good number of different product models are there, and of course their volumes will differ. We call the several product volume mix is available. But it is easier to say, it is attractive to look at, but it poses a lot of complexities or the challenges to the manufacturing people. So if those problems can be addressed successfully by scientific method following the by the production people, they feel proud of that. Capacity utilization. Better the capacity utilization, better will be the, that means that justifies the higher efficiency, higher productivity, higher throughput of the production system, which are the key performance indicator of the production people associated with the shop floor of the production department, and those are some of the major criteria which can play a very extremely crucial role in their career prospect or their career growth. So marketing people hardly bothers about the intricacies, about the details. They are only interested about the high turnover. So there is a conflicting attitude or the confliction between the within the organization, within their own department. One is marketing and other is the production. So some challenges are from the external, some from the internal. So in that under the prevailing situation, the manufacturing system must showcase certain order winning criteria. What is the order winning criteria? That means they will focus or prioritize certain amount of attributes or the features where they should concentrate so that those parameters can be adjusted suitably to bag the market. That means their product will be sold to the customer in a large quantity as compared to the customer. That is what exactly is called order winning criteria. The most fundamental being the price. It is customer is not willing to pay very high amount of price for their product. So in the competitive market, price should be as low or as reasonable as possible. If the price is exorbitantly high for any product, people will quickly switch over to the competitors, and that is how they will lose the market or the business possibilities. Quality, as I had mentioned, the very stringent, remarkable quality has to be maintained. Lead time. Lead time means it is the time duration between the when the people conceive an idea and when it is carried out or it is materialized. This time frame is known as lead time. So that lead time should be as low as possible. That means product conceptualization up to the product realization. This time span is known as the lead time. That means design, documentation, marketing, your inventory planning, material procurement, production, quality check, painting, assembly, everything to be carried out. So that time from the conceptualization to the product realization, this phase should be as low as possible, and that is technically called lead time. With responsiveness to accommodate changes. Customer may be looking for some typical features which must be incorporated in their product. So how fast or how quickly company could or the manufacturing organization can respond to that to accommodate that particular changes. Flexibility of operations. Since there are wide varieties in the product volume mix, so unless and until there is adequate flexibility prevailing in the manufacturing system, it is very difficult to manufacture the product at a competitive rate. Design leadership innovation. In the 21st century, the design leadership or the innovation is extremely crucial. Even in the current industry 5.0 also emphasizes or highlight that particular term, the innovative product or the innovation to the design leadership. Delivery schedule. Strict delivery schedule to be maintained, otherwise reputation will be affected, which may encash by the other competitors. Reliability. The product must showcase during its operation a reliable operations. Otherwise, if there is a possibility of the frequent breakdown of the maintenance, customers will not be satisfied. So, reliable performance is always expected and should be given due importance while considering a particular design of the manufacturing system. User friendliness. How easy a particular customer can use that particular product. If a lot of difficulties are faced by the customer while using that particular product, it will be accepted by the customers or the people. And the low frequent maintenance should be avoided. So the maintenance should be as low as possible. So these are the few order winning criteria which must be addressed by the manufacturing systems. So following 7 world-class measures must be addressed by the manufacturer. First of all, design and manufacturing lead time by product. That means that product must exhibit that its design and manufacturing lead time is as low as possible. So when the product is conceived, it will not take much time to bring its first model to the market. Inventory turn by product. Inventory is basically stocked item, raw materials, consumables which are procured, stored, and depending on the manufacturing schedule or the production schedule, these are consumed and eventually those stock to be replenished by the fresh arrival. Now, if the inventory flow is high enough, that symbolizes very quickly raw materials are consumed towards the development of the manufacturing of the final product. So that is a positive indication that lead time should be as low as possible, which can also be it is another alternative approach to judge your lead time, which is known as inventory turn by product. Setup times of the production equipment. Product setup time is basically unproductive or the idle time. So attempt must be paid or the equipment or the resources should be such so that setup time should be as low as possible. Production efficiency by product. Efficiency is always given the due importance. Productivity, throughput, efficiency, these are very prominent and leading key performance indicator which are very extremely crucial to judge the performance of any manufacturing system. So efficiency of the production system should be as high as possible. Employee output per productivity by product. That means for one particular product, what is the contribution of the productivity of the individual employee? That is also counted. That means what is the contribution of one single employee in that particular product. Total quality and reward. In the current days, we cannot rely or we cannot follow the so-called post-mortem type inspection system. Rather, we have to follow the total quality management. That means quality should be imbibed into the system. It cannot be inspected because inspection is basically a post-mortem type. So when fault or the is already occurred or there is some defect in the product, there will be no other way but to either rectify or make it to scrap, involving a lot of cost and money. So that is not at all desirable. So whatever process we follow, it must ensure the quality is maintained and that is how the possibility of rework should be brought to the zero or minimum. The number of suggestions per day per employee, that is a part of your continuous improvement philosophy, and so always regarding the performance, whatever may be the performance, even if it is very satisfactory, still people should not be complacent with that level, and there is every scope and the possibility that people should come up with some sorts of suggestion, so that tomorrow, that means in the next iteration, there will be some possibility of improvement. So more the suggestions, there will be more possibility of improvement and reducing the cost. From the pictorial point of view, if I categorize the three broad areas as we had discussed in the manufacturing, design is one major area, production, that means conversion of raw material to the finished goods by resources and the equipment, that is another area, and all other activities, that is manufacturing planning, scheduling, process planning, routing, dispatching, quality control, everything is covered broadly under the manufacturing planning and control. So this intersection shows that computer integrated manufacturing is basically integration of all the related activities to satisfy the customer requirements. So CIM can be envisaged as an integration of broadly the design, manufacturing, planning and control, that is the MPC, and production itself. So this production planning and control also consider a particular your managerial term of the activities popularly known as manufacturing execution systems. So manufacturing execution systems will closely plan and monitor by collecting the feedback from the real production system. If there is any discrepancy, so corrective measure has to be taken so as to bring or so as to remove that particular error or discrepancy to zero or to the minimum. So broadly, design, manufacturing execution system and production itself comprises the computer integrated manufacturing. As per Computer and Automation System of, that is the CASA of SME, stands for Society of Manufacturing Engineers, CIM is the integration of the total manufacturing enterprise through the use of integrated systems and data communications coupled with new managerial philosophies that improve organizational and personal efficiency. So this particular definition has got certain key terms. CIM is the integration of the total manufacturing enterprise. That means each activities, although individually there may be presence of automation, but that should be integrated to a common database. So it relies or it emphasizes on the integration aspect. So how? Through the data communication and network coupled with new managerial philosophies which improve organizational and personal efficiency. That means organizational activities, organizational growth, as well as the human or the personal growth, both should be addressed appropriately under the CIM activities or under the CIM paradigm. So CIM is the complete integration of all islands of automation. This is what exactly I was talking about. There are different islands of automation like design, that is the CAD, manufacturing, CAM, computer aided process planning, CAPP, computer aided inspection, CAI, but those are islands of automation. Whereas CIM relies on the integration aspect, and it has got certain advantages that we will discuss afterwards, and how that is the data communication and networking by creating a hierarchical control. That is the CIM common or central database acts as the supervisor and generates a hierarchical systems. So this is what exactly I was talking about. I have considered 9 different islands of automation: marketing, design, purchase, manufacturing, planning, control, that is the MES function, planning and control. Manufacturing control I have taken separately. Planning is the before execution, during production, the control should be enabled. Finance, because without money it is not possible to do any work. So finance, since we rely on the data communication and the network, IT has to be there. It is all about the human and machine, so HR part will be there. After completion, the product should be transported to the warehouse. So warehouse is where, and marketing people is the basically your interface between the customer and the organization. So 9 department, although they are usually under normal circumstances, they work separately, but here they must have their automated system to the computerization, and most importantly, they should be connected to the central computer through data communication and networking. That is the main theme of computer integrated manufacturing. This what exactly is the called? These are called individual island of automation, and computer integrated manufacturing integrates all the islands to a central database or central computing system, which acts as a supervisor, thereby creating a hierarchical system. This is a pictorial CIM wheel which was also developed by the SME. It has got a very broad perspective. You see that this is represented by some 3 or 4 or 5 levels of concentric circle, where at the center, which is known as the identified or considered as a nucleus, that is the customer. Why the organization exists? Organization will exist only if the customer buy their product and remain satisfied, so that it will have a cumulative effect. So at the center, as a nucleus, the customer, the focus should be to satisfy the need of the customer. So customer is at the center. How or where? That comes in the second level. So the organization, who are the different stakeholders? People. Of course, machines are there, but it talks about that teamwork. So people alone cannot do. So if you once again, if you go back and think just a minute, so there are different. It just consider different people are looking after this department, but their individual contribution cannot help to attain the global goal of the organization. It requires a coordinated attempt. There lies the importance of the teamwork. So that is successfully captured by the teamwork in the CIM, that is in the second level. In the third, what is the objective of this common database? What I am talking about? This computer, your central database or the common database having the objective is of shared knowledge. What is the necessity of the shared knowledge? What design people are doing, manufacturing people can also have an access to see how the design is being carried out. What would be the size of the component? What is the material? What are the different features? Whether my workshop facilities are sufficient or adequate to make those complex shapes. Purchase people can intervene and can see his or her involvement regarding the procurement of material, whether that particular material is specified in the bill of material which is readily available in the market or not. So everyone can see, and cross-function activities can take place that to see our involvement. That is what exactly is basically the common database, which is known as shared knowledge. And for that particular purpose, we must provide certain system, that is the networking system or the data communication systems. In the number 4, there are business definition, there are system design, component design, continuous improvement, different activities which ought to be taken care of. Those are specified toward the periphery in the level 4. So at the center it is in the hierarchy. As we come down or we move toward the periphery in the level 4, level 5, we will be coming to the lower level. That is what are we have to decompose into the different, I would say, the atomic level of activities that the system would ought to perform. So system design, business definition, life cycle transition, customer service, sales promotion. So wide varieties of activities to be carried out. And finally, at the last level, we have got the people, materials, tools as a resources, and of course information technology and suppliers or vendors to have a very successful and efficient supply chain. And on the other side, what are the responsibilities? Here, quite often we lack in understanding that CIM is not only about the technologies, but it has got a very crucial responsibility toward the society, toward the prevailing rules and regulations, toward the different laws, and of course, its responsibility toward the environmental protection and ethical aspect. So, employee, investor, community, regulatory bodies like Pollution Control Board, environmental protection to reduce the environmental hazards, and of course, values and ethics. So, everything has to be covered up in that while implementing the CIM in its true perspective. So CIM is more about philosophy rather than technology. It is not merely a collection of hardware and software. It is not a sophistication that is procured from the market and put into operation. If that is so, if the idea is so, then it will be misleading. So CIM encapsulates the following criteria: customer satisfaction as the most important business goal. Embraces TQM, that is the total quality management, which I was referring to a couple of slides back. It values the ideas of every employee. That is what I have mentioned. Number of suggestions per employee. So everyone, irrespective of their asylum, should come up with some sorts of suggestion so that there may be some scope for, even if it is implemented, but still it may play a very important or the crucial role. It does not accept status quo, rather it relies on continuous improvement. Now, for the CIM, there is another paradigm, that is what the concept that is called concurrent engineering. Concurrent engineering is an approach followed for new product development, because CIM essentially was considered to advance the manufacturing, considering the new product development. So by formulating a cross-functional team where members are present from different wings to sort out bottlenecks at the early stage, thereby eliminating all psychological and operational barriers. What is the psychological and operational barriers? Psychological means just you consider the two departments, design and the production. Design people, particularly in the CAD environment, people usually have a, we call it white collar job. That means they have got their AC room, they have got very sophisticated computers. So they are working live, and their duration, their leave, these are much more favorable. But in the production, is the condition is not that much sophisticated. Rather, people ought to work under the adverse condition, in the sense there may be humidity, there may be noise, there may be temperature, there may be continuous physical movement, and the number of holidays of the week are rather less. So in the same organization, two different group of people are having two different type of facilities of the ambience. So that creates the psychological barrier, and of course the operational barriers are also there. So that creates the bottlenecks, and why concurrent engineering emphasizes that the cross-functional team. Once again, I will just quickly have a glimpse of this. This is what exactly is the cross-functional team. That means simultaneously design, purchase, manufacturing planning, manufacturing control people can come out with their opinion, their views, so that majority of the problems can be sorted out at the early stage of the product development. That increases the efficiency and cut down the idle time and reduce the lead time of the manufacturing. That is the most crucial aspect of the competent integrated manufacturing. So characteristics, this is what exactly is called simultaneous activities by several departments. In the traditional approach, marketing, then design, then manufacturing planning, then control, then quality control, then inspection, then painting. But here, design, your purchase activities, manufacturing planning, quality control planning, all can be taken care of simultaneously, thereby reducing the lead time. That is the most attractive feature of the concurrent engineering, which is intertwined with the concept of computer integrated manufacturing. All efforts are unified to achieve the common organization goal. So individual or the departmental barriers should be removed so that they can work in a unified manner. Substantial reduction in lead time. That is the very attractive advantage of this computer integrated manufacturing system. Eliminate psychological and operational barriers. When people work in coordination almost simultaneously, those prevalent psychological and operational barriers will be removed, because all are using the same common computer platform and the common database. Amenable for computerization, obviously, no duplication of efforts. Quite often, since in the traditional approach, work or the activities are carried out sequentially, one after another, there may be a possibility of the duplication of effort. Say for instance, CAD. If we carry out computer-aided design and computer-aided manufacturing without integration separately, then there will be possibility of duplication. In the CAD platform, we have to create the drawing by some AutoCAD or some Pro Engineering or whatever may be your graphic software. Then during programming phase, once again, we have to create the geometry. Then you go for your code development. So there is a duplication of effort. But whenever there is an integration like CIM, whatever CAD module or the CAD model is generated, the automatically by integrating with the CAD with the CAM and fortified with your machine tool data or the cutting tool data, you can create the program automatically, thereby reducing the time and most importantly by eliminating the possibility of the duplication. That enhances flexibility as well. So these are some of the characteristics. Activities are performed one after it is in the sequential engineering. So in the traditional, we follow sequential. What is key feature of computer engineering manufacturing? That is the concurrent engineering. That means different works should be carried out simultaneously. In the sequential, that is the traditional, activities are performed one after another without any consultation with each other. Bottlenecks created throughout the product development cycle are more profound, very high lead time and hence not accepted. Afterwards, we have drawing will explain it better. Mental barrier is pronounced and hence efforts are far from reaching global objective. Mental barriers is pronounced because once again, marketing people different ambience, design people different work culture, production people different work culture. So there will be a mental differences of the psychological barrier. Cost of development is very high. See, the activities are quite often duplicate in nature and performed one after another. Lot of idle time needs to be incurred, which in other words, it enhances the cost of the production. Lacks flexibility. Customer request cannot be accommodated easily because if the customer offer or if customer come up with some new requirement or new ideas which needs to be satisfied, then you have to start from the very design. So once again, the same path to be followed in a repeated manner. So number of iterations from start to end needs to be followed once again. That enhance or multiply the time by considerable amount. So repetitions of work possibly is much more, and progress is not satisfactory in the tradition. This diagram will depict how concurrent and the sequential engineering can differ. In the sequential, that is the traditional, you see four different activities are considered. Say task A, B, C and D. So these A, B, C, D are taking place in sequence. When task A, which is supposed to take 4 weeks time, then only task B will start, which will again consume 2 weeks of time. Task C will take another 6 weeks of time. So if we add, so your cumulative time requirement will be 4 plus 2 plus 6 plus 4. Okay, so none of the work is taken care of or executed parallelly. But in contrast, concurrent engineering, before completion of the task A, which will take 4 weeks time, task B of 2 weeks duration can be started. So there is a overlap. So that is the beauty of this concurrent engineering. So in the current day, in the concurrent engineering, as compared to the sequential, your total time requirement will be much less as compared to the sequential engineering, with added advantage that we had mentioned earlier. This is a pictorial comparison. You see, there are two different colors are considered. For concurrent engineering, green color is followed, and for traditional, blue color. You see, with the passage of time, how many number of design changes are taking place. For concurrent engineering, in the early stage, your changes or the variations are much more pronounced. But as the time progresses, it keeps on decreasing. So when the physical manufacturing starts or the production starts, the variation of the design anomalies are reduced to almost very small. But since in case of your traditional engineering, quite often there is a intervention by other departments, so the need for changes is very frequent and abrupt. That is why it is zigzag type. So even when the production has already started, still there may be requirement that there is some deficiency in the design which ought to be changed, otherwise manufacturing will not be possible. So this simple diagram shows that in concurrent engineering, that is in case of CIM, majority of the problems of the design problems can be sorted out at the early stage and thereby dissipating the variations in the toward the end, during the production onwards. But it is continuous. So that creates your bottleneck or the ripple effect in case of your traditional engineering. That is how the concurrent engineering is advantageous and attractive. Finally, successful implementation of CIM is a three-tier process. Assessment of the existing situation, that is the technology, in terms of technology, in terms of human resource, in terms of systems. Second step, simplification. Identify come to the atomic level. If there is a possibility of the elimination of the waste, any task, any activities which does not add any value is known as waste. So attempt must be made how to reduce or how to eliminate those unwanted tasks so that we can save our time and money, and we can reduce the cost of manufacturing and the product development. Emphasis should be given on the value addition process and elimination of cost addition process. Implementation with performance measure. Whatever modification, whatever added system, software, communication system we add on to it, identify or measure its performance. If there is any improvement, then go for enhancement. So these are the couple of benefits that we can accrue by following CIM. Better customer satisfaction through lower manufacturing cost and lead time. That is the very attractive from the customer point of view. Improved quality, less scrap and rework, greater flexibility and quick responsiveness. What are the requirements which we have discussed in the beginning? Those are addressed, and those are the tangible benefits which the CIM system offers. Better production control, higher competitive edge, smaller batch size, last minute changes can be incorporated. These last minute changes come usually from the customer. Reduced work in progress, because the stagnant work is nothing but the accumulation of the money. So attempt must be made that the work in progress should be as low as possible, and it encourages or the boosts teamwork. Finally, there are a couple of barriers: lack of management perception and attitude. Actually, it is the same concept as I had shown in the very first time. It has become popular in the 80s and 90s, but unfortunately, CIM was not very successful because the lack of perception, lack of understanding. People thought, or the management people thought, that it is basically a mix of hardware and software. So more investment, more sophisticated equipment, automatically result will yield to achieve the CIM philosophy as a target. But eventually, it was proved to be wrong. That we are only investing a lot of money for state-of-the-art equipment cannot yield desired results. So it requires proper understanding what exactly we want to achieve. Unless the teamwork is enforced, unless the common database is successfully and efficiently utilized, we cannot accrue the potential benefit of the CIM system. And the entire organization, from the top to bottom, they must understand the main philosophy, how CIM system or the understanding can improve the efficiency, not merely the return on investment aspect. Lack of planning, integration challenge. Although we talk about the seamless integration, but it is really difficult in the reality to integrate the different software, hardware. That is interoperability, maybe global are the very prominent issues. Improper organization structure, difficulties encountered in communication. So communication, interoperability, ontology, these are very crucial role in IT systems. So it is extremely difficult to ensure completely seamless communications. So that is why CIM also was not become extremely popular. Another deficiency as well as CIM, there is the hierarchical structure. It is a rigid orthodox that prohibits or inhibits some amount of what is called lack of flexibility. So afterwards, as the challenge increased, there was a need for to migrate from hierarchical to the heterarchical architecture. So eventually, following manufacturing system and agent-based system, and these hybrid or the heterarchical architecture were much more flexible, agile, and responsive. So that is perhaps all about this computer integrated manufacturing as far as your CIM content and the syllabus is concerned. That is the highest level, that is the enterprise level integrated system as a part of automation. Thank you very much. That's all.